So for this video, we're going to take a look at solving rational inequalities by graphing. So we have this inequality here, 6 plus 30 over x minus 1 is less than 7. So in the beginning, we want to take the same approach as if it was an equality, and we want to graph it. So we need to get everything on one side of the equal sign. So if we bring the 7 over, we have 6 subtract 7 plus 30 over x minus 1 is less than 0. So I end up with negative 1 plus 30 over x minus 1 is less than 0. Now, in order to understand this this expression here, I want to get a common denominator. So I'm going to have a common denominator of x minus 1, which means that I'm going to have negative 1 times x minus 1 in the numerator and x minus 1 in the denominator, plus 30 over x minus 1 is all less than 0. So now I can add those two expressions together, and I get negative 1 times x minus 1 plus 30 all over x minus 1 is less than 0. And when I simplify this expression, I'm going to have negative 1 times x, which is negative x, negative 1 times negative 1, which is positive 1, plus 30 all over x minus 1 is less than 0. And my numerator now simplifies to negative x plus 31 all over x minus 1. Now, because I normally don't have a negative x expression when I'm dealing with a factor, I'm going to actually factor out that negative 1. So I'm going to have negative 1, and I'm going to have x subtract 31 all over x minus 1 is less than 0. And then what am I going to do? Well, because I have a negative here, I'm actually going to divide both sides by negative 1, and I'm going to be left with x minus 31 over x minus 1. And then because I divided by negative 1, my sign changes to a greater than, and 0 divided by negative 1 is just 0. So now what I want to do is, this is the expression that I am going to use when I graph so that I can figure out what x values will be greater than 0. So in order to graph, I need to figure out a couple of things. I need to figure out my asymptotes and my intercepts. So if you remember back to our graphing unit, I get my vertical asymptote from the denominator. So the vertical asymptote is x equals 1. And I get my x-intercepts from the numerator. So my x-intercepts is going to be, by solving the numerator, x minus 31 equals 0. So x equals 31. So my x-intercept is going to be at 31 and 0. Now, my horizontal asymptote, if you remember, if the degree of the numerator and the degree of the denominator is the same, then we just divide the coefficients. So we have 1x and 1x. So my horizontal asymptote is going to be y equals 1 over 1, which is just 1. And then to calculate my y-intercept, I just make my x's 0. As soon as I make my x's 0, I have negative 31 over negative 1, which is just 31. So now I want to graph this. So I'm going to take a piece of graph paper, and I'm going to graph it. So first, I have a vertical asymptote at x equals 1 and a horizontal asymptote at y equals 1. And then I have a y and x-intercept at 31. Whew! So when I take my graph paper here, I'm going to get rid of the numbers and make these go up by 20s, because They're not going to work otherwise. So I'm going to have negative 20, and I'm going to have positive 20 and positive 40. So I've got 1, 2, 3, 4, 5. So we'll be going up by 4s, 4, 8, 12, 16, 20, etc. So when I graph my asymptote at x equals 1, it's pretty close. These are some ugly numbers. And then I'm going to graph the horizontal asymptote at y equals 1. And then I'm going to graph at 30, so 20, 24, 28, 32. So around here at 31, and then I'm obviously going to have to change these as well. So why don't we do 10, 20, 30, and 40, and negative 10, negative 20, negative 30, and negative 40. So I can graph 10, 20, 30, 1. I can put my y-intercept. So I'm going to have a graph that does something like this, passing through and then approaching y equals 1. And my other one is going to do something like this, approaching and appearing to look like x equals 1. So my graph is going to look something like that. I can now take a look at it, and I want to figure out where my graph is based on my previous amount of work, sorry about this, greater than 0. So if I take a look at my graph, it is going to be greater than 0 between negative infinity and x equals 1. So then x is going to be between negative infinity and 1. And I'm done. So what I want you to know, actually I'm not done. Sorry. So all here, I'm above the x-axis. I'm also above the x-axis here because I'm approaching y equals 1. So I have passed through the x-axis, and from here to here, I'm also positive. So that is going to be in union with 31 and infinity. So both, this is all above the x-axis, and then this bit here is all above the x-axis. So if you'll notice that you can go from being a positive function to a negative function at an asymptote, and you can also go from being a negative function to a positive function at an intercept. So it's important to check both. When we're looking at solving rational inequalities using interval tables, that'll become very important. Anyway, have a good night. Carolyn.